Welcome to the presentation, Get Up to Speed with Partial Clone and Shallow Clone. In this session, we will explore the concepts of partial and shallow clones in Git, their benefits, and how they can improve your workflow efficiency. In this introduction, we'll cover the basics of Git, a distributed version control system, and highlight the problem with full repository clones. We will then introduce partial and shallow clones as solutions to mitigate these issues. This section provides an overview of different types of Git clones. We'll compare full clones, which download the entire repository, with partial clones, which download only selected parts, and shallow clones, which limit the history depth. Full clones download all data from the repository. We'll discuss the different Git object types involved in a full clone, including blobs for file contents, trees for directories, and commits for snapshots in time. Here, we delve into how data is represented in a full clone. Commits point to trees, which in turn point to blobs and other trees. This diagram illustrates the relationships between these Git objects. Partial clones allow you to selectively download parts of a repository using specific filters. We'll explain the command syntax and the trade-offs involved in using partial clones. Blobless clones use the git clone filter equals blob none command to download commits and trees, but fetch blobs only when needed. This reduces initial clone size and improves performance for large repositories. The main benefits of blobless clones include faster clone times and reduced data usage. This is especially beneficial for large repositories with numerous blobs. Blobless clones are ideal for developers who perform multiple builds and need a quick start. They also work efficiently with commands like git log. Treeless clones use the git clone filter equals tree, 0 command to download only commits, fetching trees and blobs on demand. This approach further reduces the initial clone size. Treeless clones offer even faster clone times than blobless clones and are ideal for continuous integration (CI) environments where speed is crucial. Despite their speed, treeless clones have limitations, such as slower operations for commands like git checkout and git log path. They are not recommended for daily development due to these drawbacks. Shallow clones, created with the git clone depth equals 1 command, truncate the commit history and fetch only the latest data. This makes them the fastest clone option available. Shallow clones are beneficial for their extremely fast clone times and are particularly useful in build environments where only the latest code is needed. However, shallow clones have limitations, including restricted history commands and more expensive fetch operations when deeper history is needed. This section compares the data download requirements of different clone options. Full clones download all data, while blobless and treeless clones download progressively less, making them more efficient. Full clones are best suited for distributed workflows and medium-sized repositories where the entire history and data are needed. Blobless clones are recommended for large repositories with many blobs. However, they come with the trade-off of slower performance for certain commands like git blame and git checkout. Treeless clones are ideal for CI builds due to their fast clone times, but they incur higher costs for fetching trees, making them less suitable for everyday development. Shallow clones are best for single-use builds, where only the latest code is required. They are not recommended for development due to limited access to history. In conclusion, it's important to choose the right clone type based on your needs. Using the latest version of Git can provide significant performance improvements. Thank you for your attention. For more information, please visit the SRK Master Stack linked here.